Hey everyone, welcome back to another episode of sound design for video games. In this episode we're going to be adding convolution reverbs to our sounds. So what we have here is a nice forest area and we have a tunnel area. What I want to do is I want to add a forest convolution reverb to our sounds when we're outside of the tunnel. And then when we go in the tunnel, we're going to be adding a tunnel convolution reverb. So what I'm going to do now is I'm going to show you an example of what it sounds like without the reverb. Well, I'll show you with the reverb first, and I'll show you without the reverb, and hopefully you can hear how big a difference this makes to the sound. First thing you're going to need to make a convolution reverb work is an impulse response. Now in Unreal Engine it's very easy to make an impulse response. You simply right click on an audio file. For instance, I've loaded up here Explosion, which is a sound wave that is available to you in the starter contents, and I can click on create impulse response and you can see this one's created here. Now what is an impulse response? What is the importance of it to a convolution reverb? Well, convolution reverb is essentially looking at that audio wave file and it's looking at how the sound decays over a period of time and how the different frequencies are dampening over that period of time. So an impulse response, if it's done correctly, is essentially a snapshot of an acoustic space. Now the issue with using the explosion, which is freely available to you in the starter contents, is that it has lots of low frequency energy, so the reverb you're going to be making from this is going to be very muddy. The other problem is it takes a very long time to decay. We're typically speaking impulse responses are very, very fast. They go, and then that's it, they've decayed very quickly, and that gives the convolution reverb the information it needs to essentially reproduce that acoustic space digitally. So I'll play this explosion now. So that is going to be a very long decay and lots of low frequency energy, which is going to result in a very muddy reverb. Now for educational purposes, you can use that. It's available to you. If you're looking for quality and you want the sound to sound good, available in my sound pack is a sound wave impulse response forest and a sound wave impulse response tunnel, which is perfect for this tutorial if you're following along, especially if you have a little tunnel area in your level. If you go to sotasound.co.uk, you can find my two sample packs here. There's a free version and then there's a full version. Unfortunately, this is the first time in the entire course where you won't get the impulse responses in the free version. The reason I've done this is because you can just use the explosion sound in the starter content and that'll be perfectly fine for educational purposes. If you require something that is higher quality and sounds better, you want to go for the sound design full, which is just £10. Now, if you're using the explosion, simply right click on that sound wave and click create impulse response. If you're using these two, the forest and the tunnel, right click on these sound waves, create impulse response, do the same for the tunnel, create impulse response. Now I'm going to show you the settings that I used when I tested the three of these. So if you're using the explosion, you probably want this at like -30. Let's just pop that over here. Now on the next one, the forest, when I tested this, -3 sounded good. And then on the tunnel, if you open that one up, I know on the tunnel, -4 sounded good, -4 decibels. Oh, and both of these can be set to true stereo. The reason being that they are stereo impulse responses. So if you're using impulse responses from the paid sample pack, they can both be set to true stereo. Now that you've created the impulse responses, we can now go through the procedure of creating essentially convolution reverb, which is going to load these in. Now what we want to do is we want to send audio into this convolution reverb as a bus send, so that essentially we still have the dry sound of the engine, but it's getting sent essentially in a parallel channel. A parallel channel of that audio is going to be getting sent to that reverb, and we're going to get that nice sort of wet reverb sound as well as the dry sound. Now to do that, there's a few ways you can do that. The first way you can do it is to create a source bus within the sound itself. So this is the engine meta sound. If I click on source here and go down to the details panel, and then if you look at the effects, source, and then look for pre-effect bus sends, and then you can see here sound source bus. You see I've already got this being sent to tunnel. I've also got one being sent to reverb forest, and what these are source buses. So if I click on this, you can see there's an option here, create new asset, source bus. If you click that, it'll prompt you, it'll say, well, where do you want this source bus to be? The other way you can create a source bus is just in the panel area. This is how I prefer to do it. So if I go to audio, source, and then source bus, and I'm going to name this 01 source bus. So that's the first stage to doing it. Once you've done that, open it up, and then you will be setting this to stereo in this instance. If I go down to effects, you can see now there's an option here for source effect chain. If you click on this, there's an option to create a new asset called source effect chain. So create that. I'm going to name this 02 source effect chain, and I'm going to put this in exactly the same folder, audio sends tutorial, and save it in there. And then you can open that up just from within here by double clicking on this little sort of thumbnail here. So we can open that up. Let's pop that here. So we have created a source bus. We have then created a source effect chain. Let me just put the little underscore on here. The next thing you need to do is in this little source effect, and then you go to chain, you can click the little plus icon, open up the index, and then from here you can create a source effect preset. So there's an entire procedure you need to get through until eventually you can create a convolution reverb. So if you create a source effect preset, it once again prompt where do you want it. We're going to put it inside of the audio sends tutorial. I'm going to call this 03 source effect presets. And because I know the type of preset that I want as a convolution reverb, I'm just going to call this conv rev for convolution reverb. Once you save this, it's going to open up a box and you'll be able to pick a type of effect that you want this to be. So you can see there's lots of different options. You can have a chorus, there's the one we want, convolution reverb, dynamic processor preset, which I'm guessing is like a compressor, bit crusher, filter, EQ. There's tons of options here. Have a little go with and see what they all do. The one we want is convolution reverb, so we're going to select that. Now that has created a convolution reverb. We can open up this by clicking on this, and there's our convolution reverb. You can see that this is all saved here now. And now within the convolution reverb, we can load in our impulse response that we created at the start. So I'm going to load in our forest sound. So the forest sound that I created for this tutorial was this one, wasn't it? Soundwave impulse response forest 1. Now, once you've done all that, the next thing you need to do is essentially send the audio into the source bus we've just created, and then the source bus will send it through to the source effect chain, and then the source effect preset, which is where our convolution reverb actually is. So if I open up our engine meta sound here, just to use an example, and I click on the source area, go down to the details panel, look for effects, source, and then on pre-effect bus sends, you'll be clicking the little plus icon to add an index here. I've already got mine sending through to my reverbs here and here, but I've created a fourth one down here which is empty just to demonstrate it for you guys. So on sound source bus here, you'll be loading in the one you've just created. So say for instance this is your forest source bus, which is loading in the forest reverb. You load that in, and now this engine sound is being sent to that source bus. Now as it stands, that won't do anything, because that source bus actually needs to be placed in the world. So if I go to my level here, you can see I've got little speakers, and these speakers are source buses. So this is my audio source bus verb forest, which I had already created. And inside of the tunnel, I have one right here, which is called audio source bus verb tunnel. This one's a little bit different because I want this one to attenuate and accentuate based on as you enter the tunnel. So as you enter the tunnel, I want that reverb to go up in volume. And as you exit the tunnel, I want that reverb to go down in volume. So this one's set up a little bit differently to the forest one, because the forest one I just want to basically be omnipresent. It should just always have that reverb, because in real life it would be like the engine and the tire screeches are essentially diffusing and reflecting off these trees and anything that's in the forest. So it should just always be the case. Where with the forest where with the tunnel we're going in and out of that. So that's set up a little bit differently in terms of its attenuation settings, which we'll go through in a minute. So what you want to do is, let's go ahead and actually grab our source bus. So here's the source bus we've just created. You can just drag that into the world, place it wherever you like. And let me see how I've set this one up. I believe I haven't done anything with this. So it's just allow spatialisation on the attenuation settings. And I think that's it. So when you drag this into the world, just have allow spatialisation on. And that's how we set up that source bus. Now, when you open up the game, you should now have whatever audio you want sending through to that convolution reverb. That should be coming through. If you're not sure whether you can hear it or not, just turn the volume of it up. And then if you hear the volume change, if you hear that reverb start to come through as you turn the volume multiplier up, that will hopefully mean that, yeah, it's working. So I'm actually going to get rid of this one. So you've created one for the forest. If you do have a tunnel, I want to show you how I've set this up. So this is my source bus, which I created for the tunnel. The difference with this one is that it has these inner radius circles and a fall off radius circle. So you can see these big circles. So I'm going to go through how I set this up. So if you go to the attenuation settings, we have allow spatialisation on. Override attenuation is checked, and then we've got enable volume attenuation. The attenuation function that we're using is log reverse. Now I tested a few of these, and the one which says log reverse seemed to work best. So as we come into the tunnel, we get that nice swell as we go from the outer radius into the inner radius, which is this here. And it sounded quite realistic to me. If you're outdoors and it's something that's reverberating outdoors, typically speaking, what you would want is an inverse. But I would just test these and see what sounds right to you. So I'm using a log reverse attenuation function, which seems to work well for this sort of scenario with the tunnel. For the attenuation shape, it's a sphere. The inner radius and fall off distance. Well, the inner radius is going to depend on how long your tunnel is. So typically speaking, I've got mine stretching out to about, what's that, like about a quarter. So once you're like a quarter of the way in, you are now within the inner radius of that. And then the fall off, I want that just outside of the tunnel, because as I hit this here, I want to start to hear the reverb of that tunnel emitting out. So if you think about the car engine, the way that propagates forward and everywhere, it's going to propagate into the tunnel, and then that's going to reverberate back out even here. So even here, you should be able to hear that reverb already before you enter the tunnel. So that's just something to think about when you're setting these up. So that's essentially how I set up the tunnel source bus. Now the next thing we need to talk about is switching between the forest reverb and the tunnel reverb, which we're going to go through now. Now just to go over functionally what's going to happen. when we start the game, we're going to be starting off with the forest reverb. And then when we come into the tunnel, I've set up a box trigger here. When we hit this box trigger, which is called tunnel reverb trigger box, we're going to be switching on the send into the tunnel reverb source bus here. So that'll be getting switched from 0, so 0 send, to 100% send. And then when we get into this inner trigger box, we're then going to be setting up the send to the forest reverb from 100% to 0. So essentially we're using these two trigger boxes which will be referenced inside of the level blueprints to change the level of sends that we're sending to each source bus, essentially, so that we're switching on the forest reverb when we need it, and we're switching it off when we don't, and we're switching on the tunnel reverb when we need it, and we're switching that off when we come back out the other side and we no longer need it. So the first thing you want to do is go to the level blueprint. You can go to that from this section here and go to open level blueprint. Now inside of the level blueprint, we're going to go to the event begin play, and the first thing I'm doing is I'm getting the game mode and I'm setting it as a variable called game mode ? We can ignore this for now. Now once I've got the game mode, I can then get that variable, and then from there I can get the default pawn class for controller. This is going to give us a useful return value which we can convert into a string here. And then we can set that string using a variable which I've called pawn class name. Now the reason we're doing this is because you may have multiple vehicles in your game which you can choose from for a given game mode. So let's say for instance you've got 2 vehicles in your game. One, my sedan pawn, which is the little sedan which I drive around in this level, and you may also have, let's say, the sports car pawn, which is the default vehicle which comes with the starter content on the racing game in Unreal Engine. Now, when we're going through the boxes, the issue that we have is that we need to have an object reference for whenever they collide and overlap with these trigger boxes, right? And if that object reference is always changing and we are casting to them, then we could fail when we need to cast to them. So we need to check what is it that's actually going through here in what game mode, essentially. So once we checked that the pawn class is, for instance, the sedan pawn, we can then get that correct reference. So carrying on here, we have a little audio begin play. This isn't too important. This is just so that I can have audio logic for a begin play which is separate from essentially game logic in the begin play. And in here we're just setting up the reverb for the collision metal, so you can take a little look at that and see how I set that up. But what I want to focus on is essentially when we're going through the tunnel and then out of the tunnel. So that is actually happening over here. So I've got audio switching acoustics based on trigger box overlaps. So now that we've set that pawn class name over here, this is now going to enable us to work correctly with the overlaps with these trigger boxes. So to get hold of these events, you simply have it selected, so you can see this is bright orange. So we know that's selected. With that selected, you can right click and then it will automatically identify at the top here that you had that selected, and you can add an event, collision, and you have an add on actor begin overlap and also an end overlap. So this is a begin overlap, this is an end overlap, this is a begin overlap for the other trigger box which is inside. So if I go inside, so that was a begin overlap for this trigger box, and this is an end overlap for that trigger box we just highlighted. So let's focus on the trigger box on the outside. So as we are, going a bit glitchy there. So as we're coming into this tunnel, we're going to collide with this trigger box and overlap. We're going to begin overlap, which is going to fire off here. As we fire off here, we are setting up the overlap begin tunnel which is a variable which is picking up this object reference. So on the other actor, this is going to return what has just collided with it. In our case, it's going to be the sedan pawn. In your case, it might be the sports car pawn, depending on what vehicle you're using. So we've got that reference. Now that we've got that reference, we can then go into a switch on string. And this is where we're getting the pawn class name, which we set on the event begin play. So on the event begin play, we got that here. We set the pawn class name from the game mode. When game mode, get the default pawn class name, get class display name, which converts it into a into a string, and then we've set that so we know essentially what is coming through here. And if it's the sedan underscore pawn underscore C, which is the name that returns, then we can execute this logic and essentially do what we need to do. So on switch on string, we'll say is the sedan pawn underscore C. We are casting to that. So this is where if you add 100 different vehicles, it'll get quite crazy. You'll be casting to each different vehicle depending on what comes out of this switch on string. So you can imagine on a full scale game, this blueprint would get pretty crazy the more vehicles you add, essentially. Luckily, we only have one vehicle that we're dealing with, and that is the sedan pawn. So I'll show you how you set it up for one vehicle. Essentially, if you add more vehicles, it's just a case of doing the exact same logic, but you're going to be casting to a different thing each time. So for the sedan pawn C, we're going to be casting to the sedan underscore pawn, which is this vehicle that we've been using throughout this entire tutorial. Once we've cast to it, we then need to do an object reference, otherwise this will fail, obviously. That's where this is coming. So we are checking what was it that overlapped with that trigger box. We've set it here, and we can then reference that here. We can get it and then give that object reference to the cast to sedan pawn so that it will succeed. Now that that has succeeded, we can then get information from the sedan pawn. So we can reference the Metasound sound effects engine audio that's in that, which is the Metasound, which is taking care of the car engine. And we can reference the Metasound that's taking care of the tyre screeches. And we can affect how we want to send that to the convolution reverbs, essentially. So you can see here, out of the cast to sedan pawn, we've went into a set source bus send pre-effect. So essentially we have loaded in the source bus, which in this case is for the tunnel. So this is for the tunnel. As we're overlapping with that trigger box going into the tunnel, we are setting up that sound so that we are sending in a level of 1, which means 100% of the signal coming from these Metasounds is being sent to that source bus. Then we are then getting another reference here to the Metasound sound effects collision metal, and we are setting the source bus, the source effect chain, to the tunnel, essentially. The source effect chain, you may remember, is, if I go over here, this is our source effect chain. So when we created these, that there is the source effect chain, okay? So that is where we are sending off to the collision metal. That is essentially so that if we crash in the tunnel, we are making sure that our crash sounds with the tunnel reverb and not the forest reverb, essentially. And then from there, we are setting up the volume multiplier for that source effect preset chain to 1, so that the collision metal sound will actually sound. So if you want it to sound very reverby, you can switch that up. If you only want it to sound a little bit reverby, you can switch it down. And we've done a few things here as well. So that's the targets. We come out, we got the audio components, and then out of that we came out of here and we got the audio source bus verb tunnel, which is the name of my source bus, which is for the verb tunnel, which once again, this is the source bus here. So we created that. That's essentially what I'm referencing here. That's just my name for my tunnel source bus. So hopefully that makes a lot of sense. I know the name and changing is a little bit confusing, but this is just how I set it up when I was setting it up at the moment. And then when we are on actor end overlap, we can ignore all this. This is all exactly the same, but we are setting the source bus level now to 0, and we are setting the source bus level here to 0. So essentially, when we have ended the overlap with this, aka we have came out of this box, we're basically saying we don't want to hear the tunnel reverb, so send nothing to it in both these instances. Now we've got a very similar thing happening with the forest reverb. So on actor begin overlap, tunnel reverb stop forest verb. That's this inner box trigger here. Let me show you how we're setting up this. We can ignore all this because we know how that works. We're simply setting that up so that the source bus, which is taking care of the forest reverb, is being set to 0. And then on actor end overlap, we are coming out of this smaller box trigger. We're setting it up so that it's 1. So that is essentially how we are dynamically changing essentially which, oh, going a bit glitchy here. Let me just wait for a minute. There we go. Sometimes it goes a bit glitchy. So that's essentially how we're setting up. When we're outside here, we're going to hear the forest reverb. As we drive in and collide with this trigger box, it's going to switch on the tunnel reverb. As we drive a bit further in, that tunnel reverb is going to get louder due to the attenuation settings that we set up. So if I click on this little speaker, you can see the spheres and how those attenuation settings are going to help us as we drive in. So it's going to get louder, 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 louder. And then by the time we're at this point, the tunnel reverb is so loud, I'm happy via this box trigger to switch off the forest reverb. And then the forest reverb is switched off. We come out. By this point, we're going to switch the forest reverb back on. And then by this point, when we come out of this trigger box, we're going to be switching off the tunnel reverb. So that is how we set that up there. Right, so that is everything. As I drive around here, we can hear the car engine reverberating with the the forest impulse response. If I skid the tyres, so I'll try and do that. I know where I can usually do that. I can usually do that going into this fast corner here. So those little skids that you're hearing have the forest reverb as well. As we go into the tunnel, we'll hear it go nice and tunnely reverby. It's a technical term. You can actually hear very slightly there as we were coming out of the tunnel. The tyre screeches are also, they've got the tunnel reverb on. So you can hear that is all working correctly. And now hopefully you can go away, give that a little go and get working. If you need any help, just let me know in the comments. I'll catch you next time.